Good day, everyone. In this lesson, we'll be tackling about the composition of functions. So, what is the composition of functions? Given two functions, f and g, the equation defines the composition of f with g, denoted by f circle g. This is the equation. It is written as f circle g function, where f is thought to be the dependent function and g is thought to be the independent function. Remember, when obtaining the function composition, the following steps will be taken. First, create the first equation based on the definition and the given functions. Identify the dependent and independent function. To explain more, the dependent is at the left and the independent is at the right. Substitute the given expression of the dependent function for the right side of the equation. Substitute the expression of the independent function for all x's in the dependent function. To explain, in the equation, the independent variable should substitute all the x's of the dependent variable. Reduce the complexity of the resulting expression. In other words, reduce or simplify the resulting expression. Changing the order of the functions can result in composition values that are equal or unequal. We have now learned the definition and rules for solving the composition of functions. Let us now move on to the examples. This is the first example. Find the composition of f with g when f function is equals to 4x plus 3 and g function is equals to 2 minus 2x. Let us now solve for example 1. Let us write the equation. This is our equation for this example. So, let us now use the f function in the equation, which is 4x plus 3. Now, we have to substitute the x with the dependent function. This is what it looks like. The next thing we do is distribute the 4 with the numbers inside the parentheses. So, 4 multiplied by 2 becomes 8, and multiply 4 again with negative 2x, which becomes negative 8x. Then copy the positive 3. Combine the like terms and our answer is negative 8x plus 11. Therefore, the composition of f with g is negative 8x plus 11. Let's have the second example. Find the composition of m with g when m function is equals to square root of x plus 6 and g function is equals to 2x squared plus x minus 1. We can use other letters aside from f and g. The m function has a square root in it. Let us find out how we can solve it. Just like the first example, we will also write the equation. So, this is the equation. So, use the m function in the equation, which is square root of x plus 6. Let us substitute the x with the dependent function. Remove the parentheses and let us subtract the like terms. After subtracting, we now have the answer, which is square root of 2x squared plus x plus 5. Therefore, the composition of m with g is square root of 2x squared plus x plus 5. For the third example, find the composition of f with g when f function is equals to 4x minus 2 over x plus 2 and g function is equals to x squared minus 4x minus 16. This example involves fraction. Let us answer this equation. This is the equation for this example. So, let us now use the f function in the equation, which is 4x squared minus 2 over x plus 2. Again, like the previous examples, substitute the x with the dependent function. The same with the first example, we will do a distribution. Multiply 4 by x squared becomes 4x squared. 4 multiplied by 4 becomes 16. And lastly, 4 multiplied by 16 becomes 64. And copy negative 2. For the denominator, remove the parentheses. Add or subtract like terms in the equation. Our final answer would be 4x squared minus 16x plus 62 over x squared minus 4x plus 18. Therefore, the composition of f with g is 4x squared minus 16x plus 62 over x squared minus 4x plus 18. Moving on, example 4. Find the composition of f with q when f function is equals to square root of x plus 1 and q function is equals to 3x minus 2 over x plus 1. This equation also has a square root in the dependent function. Let's now answer this example. Write the equation for this example. So, let us now use the f function in the equation, which is square root of x plus 1. Substitute the x with the q function. Remove the parentheses and subtract the like terms. Since negative 2 plus 1 is equals to negative 1, our answer is now square root of 3x minus 1 over x plus 1. Therefore, the position of f with q is square root of 3x minus 1 over x plus 1. Let us now have our final example. For the last example, find the composition of b with n when b function is equals to 2x minus 1 over x plus 1, and n function is equals to x squared minus 6x plus 1. Let us now answer this equation. So, this is the equation for this example. Let us now use the b function in the equation, 2x minus 1 over x plus 1, which is a fraction. Substitute all the x's with the n function. We will do a distribution. Multiply 2 by x squared, it becomes 2x squared. 2 multiplied by 6 becomes 12. And lastly, 2 multiplied by 1 is 1. Then copy plus 1. Remove the parentheses on both the numerator and denominator. Add or subtract the like terms in this equation. Our answer now is 2x squared minus 12x plus 3 over x squared minus 6x plus 2. Therefore, the composition of b with n is 2x squared minus 12x plus 3 over x squared minus 6x plus 2. Well, that's all for today, everyone. I hope everyone understood and learned something from this discussion. Till next time, thank you and goodbye.